They lie frozen in silence, their bodies perfectly preserved for years. No heartbeat, no breathing, no aging. And yet, they are not dead. They're astronauts, placed in hypersleep, traveling through the endless void. But what if they never wake up? Welcome to Tech Science Insights. If the future fascinates you like it does us, don't forget to subscribe for more mind-bending tech stories, delivered with truth, depth, and respect. What is hypersleep? Hypersleep, also known as cryosleep or suspended animation, isn't just a sci-fi fantasy anymore. It refers to a theoretical process where the human body is placed in a deep, controlled state of sleep, often by lowering body temperature and slowing biological processes to a near stop. In theory, a person in hypersleep can travel for decades without aging, eating, or even needing oxygen in the normal way. NASA has already begun serious research on this, especially for Mars missions where astronauts may spend months or years in space. Unlike freezing in ice, hypersleep would require precise control to prevent cellular damage, organ failure, and neurological degradation. The ultimate goal? Enable humans to reach distant planets without the burden of food, space, or time. Just sleep and wake up when they arrive. Why do we need it? The universe is unbelievably vast. Even at top current speeds, it takes 7 months to reach Mars, 4 years to reach the nearest star, Proxima Centauri, if we could go fast enough. Now imagine going farther, to exoplanets, moons, or even distant galaxies. Humans simply can't survive long-term travel without massive resources, psychological stability, or long-term food and oxygen. Hypersleep solves all of this in one concept. It reduces food and oxygen needs, waste management, crew stress, boredom, and psychological burnout. And most importantly, it saves time and money in building massive spacecraft for years-long journeys. Here's where it gets fascinating. Current research into hypersleep focuses on therapeutic hypothermia. This involves cooling the human body to around 32 degrees Celsius, 89 degrees Fahrenheit, slowing down metabolism by 50 to 70%, using 4 nutrients and oxygen through assisted ventilation. This technique is already used in emergency medicine to stabilize trauma victims or during certain surgeries. NASA and SpaceWorks enterprises are now adapting this for spaceflight. But turning hours or days of hypothermia into months or years of suspended life is where science meets risk. The main hurdles are ice crystal formation in cells, tissue and brain damage, reawakening safely without permanent injury. Future solutions may involve cryoprotectants, special fluids that prevent ice damage, or even genetic modifications to allow the body to survive low temperatures more effectively. So, is hypersleep real yet? Not fully, but we're closer than ever before. SpaceWorks Enterprises has proposed a torpor habitat unit, a rotating sleep pod that could support 6 astronauts in stasis for a Mars mission. Their prediction? By 2030, short-term hypersleep trials may begin in space. However, anything longer than a few weeks remains experimental. That said, mice and certain animals like frogs, bears, and even tardigrades already survive cold stasis in nature. Scientists are studying their hibernation genes to replicate it in humans. Some researchers believe cryogenics and induced torpor could become reliable human technology within 30 to 50 years. Let's be clear. This is a prediction, not a current fact. But the scientific foundation is real and growing fast. Hypersleep isn't just technical, it's deeply ethical. What happens if someone never wakes up? Or worse, wakes up in the middle of deep space alone? Here are major concerns. Consent and risk. Would astronauts agree to such high-stakes suspension? Waking protocols. How do we revive them safely after years of sleep? Malfunction risk. What if a system fails mid-journey? Psychological trauma. Waking up after decades may be mentally damaging. And there's a spiritual question, too. What defines life when all vital signs are paused? For now, these are challenges researchers, ethicists, and space agencies must address thoroughly before any real mission. Hypersleep isn't just about space. In the future, it may revolutionize medicine, aging, and human evolution. Imagine emergency freezing during global pandemics, preserving terminal patients until cures are discovered, aging slowed or paused entirely, space tourism to other worlds in comfort and silence. But before we dream too far, one fact remains. We are only at the beginning of this journey. Humanity has always pushed the boundaries of survival, from deep-sea diving to lunar landings. Now, hypersleep may open the door to the stars. Frozen in time, awake in the future. This isn't science fiction anymore. It's science becoming real. The countdown to hypersleep has already begun.